Hi students, welcome back. In the previous class, we will discuss about Coulomb's law in electrostatics. Today we are going to discuss about electric field. Electric field is the space around the charge where its effect is felt. For this, consider charge Q. Around this charge where its effect is felt is known as electric field. Then, how to find out the intensity of electric field at a given point? To find out the intensity, we want to consider a point P in this field and place a unit positive charge at that point. Then the force exerted on this unit positive charge by the charge Q, which gives the intensity of electric field at that point. For this, if R is the distance between them, then according to Coulomb's law, the force exerted on this unit positive charge by the charge Q equal to 1 by 4 pi epsilon 0 into Q into 1 divided by R square. That's equal to 1 by 4 pi epsilon 0 into Q divided by R square. This force exerted on this unit positive charge, that will give the electric field intensity E. Now we want to write the vector form of electric field intensity. For this, vector E is equal to 1 by 4 pi epsilon 0 into Q divided by R square into R cap. R cap is the unit vector. Now, on replacing the charge plus Q plus 1 coulomb, that is on replacing plus 1 coulomb charge by a small q charge, then the force exerted by this small q charge by the capital Q charge is given by F is equal to 1 by 4 pi epsilon 0 into small q into capital Q divided by R square. Instead of this 1 by 4 pi epsilon 0 into Q divided by R square, we can write electric field intensity E. Therefore, F is equal to E into Q. F is equal to QE. In vector form, vector F is equal to Q is a scalar quantity. Therefore, Q into vector E. This is the relation between force and field. From this equation, we can write E is equal to vector E is equal to vector F divided by Q. Okay. Now we want to explain field due to system of charges. For this, we want to consider large number of charges Q1, Q2, etc. to Qn charges. To find out the electric field intensity at the point P, due to these charges, we want to place a unit positive charge at that point. That is, place 1 coulomb of charge at the point P. Then the force exerted by these charges on plus 1 coulomb of charge, which will give the electric field intensity. Q1, which is placed at a distance R1P. Q2 is at a distance R2P. Similarly, Qn is at a distance Rnp. Field at the point P due to Q1 charge can be written as vector E1P. Field at the point P due to Q1 charge, that is equal to 1 by 4 pi epsilon 0 into Q1 divided by R1P square into R1P cap. Similarly, field at the point P due to Q2 charge, E2P equal to, vector E2P is equal to 1 by 4 pi epsilon 0 into Q2 divided by R2P square into R2P cap. Then field at the point P due to Qn charge, that is vector ENP is equal to 1 by 4 pi epsilon 0 into Qn divided by Rnp square into Rnp cap. Therefore, the resultant field at the point P due to these charges equal to vector E equal to vector E1P plus vector E2P plus etc. to vector ENP. Field at the point P due to Q1, Q2, Q3 etc. to Qn charge is equal to vector E equal to vector E1P plus vector E2P plus etc. to vector ENP. Now, on substituting these values, that is E1P, E2P, E3P etc. to ENP on this equation, we can write vector E is equal to 1 by 4 pi epsilon 0 into Q1 divided by R1P square into R1P cap plus 1 by 4 pi epsilon 0 into Q2 divided by R2P square into R2P cap plus etc. to 1 by 4 pi epsilon 0 into Qn divided by Rnp square into Rnp cap. On taking the common factor outside, that is 1 by 4 pi epsilon 0 is taken outside. Then Q1 divided by R1P square into R1P cap plus Q2 divided by R2P square into R2P cap plus etc. to Qn divided by Rnp square into Rnp cap. This equation we can write 1 by 4 pi epsilon 0 into summation starting from 1 to n, that is I equal to 1 to n, Qi divided by Rip square into Rip cap. This is the field due to system of charges. The resultant electric field at any point is the vector sum of field due to individual charges. This is also known as superposition principle. That's all about today's portion. If you like this video, please subscribe and enable the bell button. Thank you.